Another type of lift check valve is a vertical lift check valve. Fluid flows through this check valve vertically, but the disc is still positioned so that fluid flow is under the disc, just as it is in other types of check valves. A variation of the lift type check valve is a ball check valve. As its name indicates, a ball check valve has a ball-shaped disc. Ball check valves can be designed to operate in either the vertical or the horizontal position. In this example, the valve operates horizontally. When fluid flows through the valve, the ball is pushed out of the seat by the pressure of the flow. As the ball is lifted, it also rotates in the fluid flow. Solid materials in the fluid can't easily stick to the spinning ball. So this makes ball check valves excellent for handling liquids that contain scale and sediment. Because the ball rotates freely when the valve is open, the ball tends to wear evenly. When flow through the valve stops, the ball is pulled onto the seat. A different surface area of the ball falls onto the seat each time flow stops. This produces a self-cleaning effect that also helps to ensure that the valve continues to close properly. If flow reverses, the backflow holds the ball firmly on the seat, keeping the valve closed. Many valves can be opened or closed manually with a hand wheel. Ordinarily, the hand wheel is located so that the person operating the valve can apply the proper force to turn the wheel. In some situations, however, this isn't possible. Often, valves must be located in relatively inaccessible places. When this is the case, adapters may be attached to the hand wheels so workers can operate the valves. A common example of such an adapter is a chain that runs through a pulley. You must always use the correct size valve wrench for the job. Attach the wrench securely to the hand wheel so the wrench won't slip off while you're applying force. Never apply excessive force when you're opening or closing a valve with a wrench. Too much force could bend or break off the hand wheel or the stem. Excessive force can also damage the valve seat and the disc. Whenever you must operate a valve manually, follow the proper procedures to ensure that you don't damage the valve. If a valve is opened with a single operating lever, such as the handle on a plug valve, simply move the handle in the open or the closed position to operate the valve. If a valve has a hand wheel, use both hands, placing one on each side of the hand wheel, to open or close the valve. This enables you to apply force evenly to the valve. If force is applied unevenly, the valve stem can be twisted, bent, or broken. When a hand wheel is used to operate a diaphragm valve, excessive force could cause the diaphragm to jam into the seat and be cut, resulting in leakage. Finally, to check if a manually operated valve is closed, try turning the hand wheel or handle in the proper direction to close the valve. This prevents undesired flow through the valve if it's already tightly closed. Many valves can be operated manually with hand wheels or with operating handles. But valves often use mechanical operators or actuators to open and close. With these devices, valves can be turned on, off, or throttled more quickly and easily than with manually operated devices. Also, when mechanical operators are used, valves can be repositioned from a central, remote location, such as a control room. Common types of mechanical operators include pneumatic, hydraulic, and electric. Pneumatic operators, or actuators, use air pressure to produce motion that positions a valve. There are several different kinds of pneumatic operators. A diaphragm actuator is a pneumatic operator that uses air acting on a flexible diaphragm to position a valve. The diaphragm is raised or lowered by variations in applied air pressure. There are different designs of diaphragm operators, but they all allow flow to be automatically regulated as system conditions change. So these types of operators are often used for throttling valves. Typically, the diaphragm separates two chambers within the body of the mechanical operator. A spring holds the valve open or closed, depending on its design, when no air pressure is being exerted on the valve. Disc movement is adjusted by varying the air pressure that's applied to the diaphragm. As air pressure is changed, the valve is opened or closed. This piston actuator is a pneumatic operator that uses a piston inside an airtight cylinder to position a valve. It's generally more suitable than a diaphragm actuator for jobs that require relatively long stem travel or more force to position a valve. This vane actuator is a pneumatic operator that uses air pressure against a vane or paddle to position a valve. This type of pneumatic operator is used primarily with ball, plug, and butterfly valves. A hydraulic operator uses the pressure of a liquid against a piston to position a valve. A hydraulic operator generally develops more force than a similarly sized pneumatic operator. Some of the force exerted on a pneumatic operator is used up in compressing the air in the operator. But since, for the most part, liquids aren't compressible, more of the force exerted on a hydraulic operator goes directly towards positioning the valve. The power supplied by hydraulic operators makes them very suitable for the operation of large valves. This is a cutaway illustration of a single-acting spring-return hydraulic valve actuator. Fluid enters the cylinder of the actuator through a port and acts on only one side of a piston. The piston can be positioned anywhere in the cylinder by controlling the amount of fluid in the cylinder. If the hydraulic fluid pressure is lost, the spring causes the valve to fail closed. This is a double-acting hydraulic valve actuator. Fluid can enter the cylinder through either of two ports. The amount of fluid filling the cylinder and being bled from the cylinder is controlled to position the valve. If fluid enters through the top port, the piston is forced down to close the valve, and an equal volume of fluid is vented through the lower port. Increasing fluid pressure through the lower port moves the piston up, opening the valve. At the same time, an equal volume of fluid flows out of the upper port. When the flow of fluid through the lower port stops, the piston is essentially held in place by the fluid that is trapped on both sides of the piston. An electric operator uses electricity to position a valve. There are various designs for these types of operators. One type of electric operator is a solenoid actuator, or simply a solenoid. It's used for on-off control of a valve. Because solenoids can go from fully open to fully closed quickly, they're particularly useful for emergency shutoff valves. But because they have no intermediate or in-between position, they can't be used to throttle a valve. Valves that have to be throttled often use operators that are driven by electric motors. The electric motor drives a set of gears that controls the travel of the valve stem, which, in turn, positions the valve. When the motor is energized, the valve stem begins its rotation to raise or lower the disc. Enclosed in the body of many electric motor operators is a torque switch, a limit switch, or both, to ensure that the valve is positioned properly without being damaged. This is a torque switch. Basically, torque is a turning or twisting force. A torque switch cuts off electric current when the amount of turning force caused by the motor reaches a preset limit. This is a limit switch. It cuts off electric current to the motor when the valve reaches a preset position. A limit switch may be used to indicate the position of a valve and to ensure that power is stopped when the valve is in the fully open or the fully closed position. Some electric motor operators can be operated manually with a hand wheel if necessary. Typically, the motor operator has a lever that connects the hand wheel to the gears and at the same time disconnects the motor from the gears.